Well, in our first example, we're given that dy dx is this function. So this is f of xy right here. F of xy, I'm just writing it really small. And our x naught is 0, and our y naught is 5. What we need to figure out is our estimate at time when x is 3. And it says use 2 steps. In order to get from 0 to 3 in 2 steps, remember that b minus a over 2? You're going from a, which is 0, to b, which is 3. 3 minus 0 divided by 2 steps gives us 1.5. So I just made h equal to 1.5. If we were using 3 steps, h would have to be 1. 1, 2, 3. 3 steps to go from 0 to 3. So we're doing this. We're going 0 to 1.5 and then to 3. So we're starting here and then 2 steps. Okay, I left the formula up down there. And so what I need now, I can go ahead and say that x0, y0 is known. That's equal to 0, 5. We need to know what x1 is. Well, we know what x1 is. It's going to be 1.5. y1 would be when I is equal to 0. That would give us a y1 here. So we're going to get y1 equals y0 plus f of x0, y0 times h. And we're going to do some computing, and that'll give us x1, y1. We know x1 is 1.5. So we're going to get y0 is a 5 plus f of 0, 5 times 1.5. Okay, f of 0.5, 0, 5. So x is a 0. E to the 0 is a 1, so that gives us a 3 minus 0.4 times 5. 0.4 times 5 is a 2. So we're getting 3 minus 2, which is equal to 1. My bad, I didn't multiply by 1.5. I better write it out. Okay, so we get 3e to the 0 minus 0.4 times y, which is a 5, then that's times 1.5. Okay, so 5 plus 3 minus 2 is 1. 1 times 1.5 is 1.5, so that's 6.5. So we get now that x1, y1 is equal to 1.5, 6.5. Now we just have one more point to go. Okay, so I'm going to squeeze it in here. Let's make I equal to 1. Because if I is equal to 1, we would get y2 equals, and so on. So that gives us y2 equals y1 plus f of x1, y1 times h. That's equal to y1 is 6.5. And again, this 6.5 is not the exact value, it's just our estimate. Plus f of this. If x is 1.5, we get 3e to the negative 1.5 minus 0.4y, but y is 6.5 times 1.5. Let's see, I plugged that in, and I got 3.604. So x2, y2 is 3, 3.604. I circled that, but really the estimate we're looking for is y of 3 equals 3.604. And as you might guess, that's not a very good estimate. It's not terrible, but the reason it's not great is we only did 2 time steps, and a 1.5 for a time step is a long ways. So we use too long of time step. The actual number is what? The exact value is y of 3 equals 2.763. So that gives us an error. The way we compute this error, I'm going to call this an absolute relative error. But I put a t here because it's the truth. We're comparing it to the known value. Normally, when you're computing the error, you don't know the known value. Otherwise, why are you bother computing it? But we do know. We know the solution to this differential equation. So this turns out to be 2.763 minus 3.604 all over 2.763 in absolute values. The true value minus our approximation, which is right here, over the true value. And that turns out to be 30%. 30.44%. So that's not very good. But again, we would never estimate the value at y.3 given the initial value at y.0 using only 2 steps.